When you have an inverse variation situation, your x values and your y values are moving in the opposite direction. There are situations where your values of y are going to decrease as your values of x increase. Okay? When you have inverse variation, you'll see words like this. You'll either see that something that says y varies inversely as x, or you might see something that says y is inversely proportional to x. And it's really important to know that inverse variation problems have a couple of rules that they always follow. And the first one, the most important one, is that in inverse variation, the product of the two values is going to remain constant. Okay, what that means, if you take your x value and your y value and multiply them together, it's always going to equal the same amount. Okay, it's always going to equal some constant amount. And if you can figure out what this constant amount is, this k value, then you can make a graph and you can know what all the combinations of variables could be. Let me give you an example here. If you were doing a problem like this, it might say something like, graph an inverse variation equation in which y varies inversely with x, and let's say y is 6 when x is 4. Okay, so the first thing you would have to do to graph this inverse variation problem is find out what's your constant. Step one is going to be to find your constant. And the way you do that is you're going to multiply x times y, which will give you that value of k. So I'm going to plug in 4 times 6, and I'm going to find out that my constant is 24. Now, if I want to graph this inverse variation problem, I need to have a y equals equation. So if we look at what we have here, if I wanted to make this y equals, all I would do is divide both sides here by x. And I could plug this into my calculator as my constant divided by x. Well, step number 2, in order for us to graph, is that we're going to take this constant and plug it into this. So if I wanted to make a graph, what I would do is I would graph 24, divided by x. And then I could create a table and make a graph. Let me show you an example. So we have this problem that says graph the inverse variation in which y varies inversely as x, y is 1 when x is 12. Okay, so that's really important. Y is 1 when x is 12. So the first thing I'm going to do is I'm going to take this equation and I'm going to try to figure out what my constant is. So I'm going to plug in my 12 for x and my 1 for y, multiply those together, and I find out that my constant here is 12. Now I want to figure out what to put into my calculator. So I'm going to take that 12. I know that x times y equals the constant, which is 12. I'm going to change it into a y equals equation by dividing both sides by x, and I find out that y equals 12 divided by x. Now it's time to create our table. So now that I know what I can plug into my calculator, I'm going to go to my calculator, and I'm going to click on y equals, and I'm going to enter this equation, 12 divided by x. And I can use that then to create my table. So I'm going to go to second and graph. Okay. Now you'll notice there are lots of decimals in this problem here. That's going to make it a little bit tricky to graph. The other thing, before we graph it, hit the graph key. I want you to see what this looks like. Okay. When you graph this, you're actually ending up with two curves, one up here and one down here. I want you to think about this. If we always get a constant amount, okay, and if we think about the table that we have here, I know that this value x times this value y is going to equal 12. Always going to equal 12. So negative 6 times negative 2 will give me that value of 12. But if I had positive 6, I'm also going to have positive 2. So a negative times a negative would give me a positive, which is why I'm getting this curve down here on the negative side. But I know a positive would also give me that 12, which is why I'm getting this curve up here. So when you create your inverse variation curves, it's really important that you remember you're going to have two curves, so you're going to have a very big table of numbers. Okay? So if you go back to your table and you want to think about which numbers are going to be easy for you to graph, you want to look for numbers that are whole numbers. You want to look for numbers that are going to fit on your graph, and use those numbers to fill in your table. So I've already got my negative 6, 2. I've got negative 4, negative 3. I skipped this negative 5 because of that decimal. I could estimate it, but I'll stick with my whole numbers for now. So I've got -3, -4, -2, -6, -1, -12, which isn't going to fit on my graph, but I can probably guess where it would be. And then I get this error message for 0. Think about it. This times this has to equal 12. Is it possible to multiply 0 times anything and get a number of 12? No, it's not. And that's why we're going to get an error message. We're never going to be able to graph an x value of 0. We're also never going to be able to graph a y value of 0. So you need to know that when you make your graphs, they're never going to cross your x-axis or your y-axis. All right, let's complete this table. We'll go down to the positive numbers here. So I'm going to have 1 and 12, 2 and 6, 3 and 4, 4 and 3, and I already did my 6 and 2. Okay, so once my table is complete, now it's time to graph. When you're graphing this, remember, it's going to make those two curves. So it's important for you to remember that your lines are not going to be continuous. They're going to look a little weird when you're graphing them. So we're going to go -3, -4, -2, -6. And I have -1, -12, which is going to be somewhere down here. So I'm going to connect these points together and make my curve. Now it's not perfect, but you get the idea. And now let's graph these bottom ones. Again, I have over 1, and I have up 12, which is not on my graph, but I can guess where it is. I'm going to go 2, 6, 3, 4, 3, 4, 4, 3, 6, 2. I'd have another one out here somewhere. And this is what this curve would look like. Okay, so that's a basic inverse variation graph. Now, sometimes you're going to be asked to graph word problems. It's the same idea, except like if you look at this graph only has positive numbers, and I'll explain why in just a second. Okay. Suppose you drive 200 miles without stopping. So that 200 miles is my constant. The time it takes varies inversely with the time at which, the time it takes varies inversely with the rate in which you travel. So the time and my rate are my two variables, x and y. So x is my speed or my rate, y is my time. And I know that x times y is going to give me that constant 200. So if I want to figure out how to graph this, I need to divide both sides by x, and it's y equals 200 over x. That's my constant. Again, go to your calculator. Go to your y equals. Hit clear. Go ahead, we're going to put in 200 divided by x. Now these numbers, again, are really big. First of all, there's a 0 message. There's an error at 0. I'm not going to be able to graph over 1 up 200. Okay, if you look at your graph, pick values that are going to be reasonable for your graph. Things are going to be easy to graph. Like I could put this 5 and 40 in there. I could put this whole numbers. Let's look for some whole numbers here. I could put this 10 and 20. So what I want to do is I want to pick a graph that's going to be reasonable. And so this is the table that I've come up with. And what I'm going to do now is I'm going to graph these points. And I've actually already got them here, so we'll just slide that over. And you can see I've got over 10, up 20, and this is what my curve would look like. And again, it's only in the positive section here because we can't have negative speeds and we can't have negative time. So in a word problem, it may be that you only have one set of curves because you can only have positive values. And that's graphing inverse variation.